Hello dear children, this is your favorite maths teacher and you are watching Triangles Part 1. And in this particular chapter, first in the introduction part, we shall try to understand what are congruent figures, similar polygons and equiangular triangles. So number 1 is congruent figures. Children, in the previous classes, you have already gone through congruent figures. Now let us refresh ourselves. On the board you can see two squares. You can see these two squares, and if you try to put one square on the other, you'll see that the squares overlap each other. Okay, in the same way you are able to see here two triangles. If you try to put one triangle on the other, you'll see that these triangles also overlap one another. See these squares and the triangle, and now come to this circle. If you put one circle on the other, you'll see that the circles overlap with one another. Now what does this show? This says that the figures are duplicate of one another. See, blue one and green one, both of them have same size, same shape. Similarly, here the triangles have same size, same shape, and when they are put on one another, they hide the figure that is below it. Same way here in case of circle. So these type of figures, or we can say that any two geometrical figures which have same shape and same size, or the figures which are duplicate to one another, are known as congruent figures. Now children, let us see what are similar figures. See, here you have seen this is a line segment, okay, and again this one is also a line segment. If you see that both the line segments look similar to one another. See here, this is a triangle, and again this is also a triangle. Both of them looks the same, but the size is different. See here, if you are putting this triangle inside this triangle, see, this angle is equal to the bigger triangle's angle. Now see, if you are putting this angle here, here also the angle of smaller triangle is equal to that angle of larger triangle. Here also, if you go and see, you'll see that this angle is also equal to the angle of the triangle which is behind it. So the triangles are similar, all angles are equal, all three angles are equal, but the only thing is one triangle is bigger and the other triangle is smaller. Here see this black square and this gray square, both of them are squares, all of them have all angles 90, all four angles are 90 in both the figures, but their size is different. So here if you see the circles, all circles look same, but their sizes are not the same. So these type of figures which look the same but have different sizes, are known as similar figures. See, one figure can be put inside the other figure if you want to see properly whether they are similar or not. Now see here. So these type of figures which look the same but have different sizes are known as similar figures. Now children, let us see what do we mean by equiangular triangles. You can see here I have shown different types of triangles. If you see this one, this triangle and this red color triangle, you can see that both of them look similar. Now two triangles which are equiangular means if their corresponding angles are equal. See, both these triangles are right angle triangles, and the angle, all the three corresponding angles of this bigger triangle is same to the smaller triangle. So the triangles whose corresponding angles are equal and whose corresponding sides are proportional are said to be as similar triangles. So two triangles, any two triangles, if you are going to take any two triangles, let me explain this. if you are going to take any two triangles, suppose we are taking this triangle, this one, suppose this is A, B, C, and then you are taking one more triangle, this is P, Q, R. Then children, you have to try to understand this, that angle A must be equal to angle P, angle R must be equal to angle B must be equal to angle Q. Both, see here I have taken both the triangles as right angle triangles. Now if you see, these angles must be equal, first thing, and second thing, the ratio of AB by PQ must be equal to the ratio of AC by PR, and that must be again equal to the ratio of BC by QR. That means, see children, again I am telling, the ratio of AB by PQ must be equal to the ratio of AC by PR, and this must be equal to the ratio of BC by QR. So then you can say that triangle ABC is similar to triangle PQR. So, first of all, equiangular triangles means two triangles having corresponding angles equal. And then from equiangular triangles, we can say that any two equiangular triangles are similar when their angles are equal and their sides, corresponding sides ratio is equal. So, see here, I have taken one more example here. If you will see properly here, this green colored figure here, this is not a right angle triangle. I have taken one another type of triangle. So this is, if you see in this triangle, you'll come to know that, suppose I take this as L, M and N. Let us say this is triangle L, M, N, and this triangle is X, Y, Z. And you can see that this angle L is equal to angle X, angle M is equal to angle Y, and angle N is equal to angle Z. So these two triangles are equiangular triangle. Now if the ratio of LM by XY will be equal to ln by xz, and then this will be equal to mn by yz, then you can say that these two triangles, that is LMN, is similar to triangle XYZ. Triangle LMN to triangle XYZ when the conditions that I have said, angle L will be equal to angle X, angle M will be equal to angle Y, angle N will be equal to angle Z, then the ratio of LM by XY equal to the ratio of LN by XZ, and that will be equal to the ratio of MN by YZ. Then we will say that triangle LMN is similar to triangle XYZ, and this symbol is known as symbol of similarity.